Hey everyone, welcome back to QA and Dev Tips. Today we are going to learn something that confuses a lot of beginners, but once you get it, it is actually very powerful. We are talking about tuples and sets in Python, and more importantly, two big ideas, immutability and uniqueness. So don't worry now, these words sound big, but I will make it super simple. So by the end of this video, you will clearly understand when to use tuple versus a set and what immutability really means and why sets remove duplicates automatically and how this will help you in real coding whether you are doing development or QA automation. So let's start simple. First of all, what is a tuple? A tuple is just a collection, like a list, but there is one major difference. You cannot change a tuple once it's created. So that's why we call it immutable. So let's see this example. So here we have defined my underscore tuple, and you can see how it is defined in this special thing 1 2 3 parenthesis, and when you print this it works like that. But if I try to change this tuple, let's say I want to do this and then say, so you can see that this will raise a type error because tuples are immutable. So let's see. So you see this throws an error. Why? As I said, because tuples are fixed. Once you defined, they are fixed, locked and unchangeable. And now let me explain immutability in a very simple way. Think of a tuple here. Think of it like a sealed box. You have a box, you sealed it, and once you sealed it, you cannot open it and change what's inside the box. So in Python terms, immutable means the object, here the my underscore tuple or any object, cannot be modified after you declare it, after you create it. But here is something interesting. You can still reassign the tuple to another tuple variable. So you can see here I have defined this, and you can still define it to the same variable, but you can assign a different tuple to the same. So that's reassigning here. This one still works. So you can see here when I print this, you can see the program works just fine. So it takes the recent value tuple that is assigned to this variable and we print it. So wait, is that changing the tuple? Because we said tuple is locked and cannot be changed, but here it is different. No, we are not changing the tuple. We are just pointing the tuple. This is a tuple data, and we are pointing a different one to the new tuple. So you can even, for convenience, you can even assign it to a new variable name, or you can overwrite the value of this tuple with another tuple. So that works just fine. The old one stays unchanged. So you can still print my tuple and it will print the old value. So you can see. And now let's talk about another example where we are creating tuples. So here I have two tuples. So both are valid. Yes, even without the parenthesis, it is still a tuple. So that's how you can declare a tuple variable here. So that works fine. Now one important real world use is that why do we even need these tuples? Here is the key reason and the key idea. Tuples are used when the data should not change. Of course, as we mentioned before, the tuple is like a sealed box. So once you defined it, you cannot change it. So in some situations, you need to keep the data fixed, like the coordinates or fixed configurations or database records, because these are immutable and they are also faster and safer. So now here is a very important concept that most beginners miss. So tuple is immutable, but it can contain mutable items. So that sounds confusing. Let's see with another example. So you can see here is a simple script, and you can see the tuple is here, but when I run this program, you can see the value of 3 is being replaced by 9. And why is that happening? We changed something inside the tuple? Yes, because this is a list inside the tuple, and this list is mutable. Although the entire tuple is a tuple indeed, but because there is a list in the tuple which is mutable, The tuple itself did not change, only the inner object changed. So you can assign it to any variable, any index you want, let's say to 1, and you can see that this is changed. So we are changing only this list, which is mutable, but this is inside the tuple. The tuple itself did not change, only the inner object changed. So now let's move on to sets. This is where things get really interesting. A set is also a collection, but with two special properties. The set cannot have duplicates, and there is no order in a set. So what does that mean? Let's take this example. So here we have a set, and you can see it is defined a set of numbers or any data strings inside a parenthesis, curly braces. So when I print this, you can see the output is, and I said before, a set cannot have duplicates. So it removed all the duplicates and printed only the unique ones. So duplicates are automatically removed. So here is the key definition of what is a set. A set is a collection of unordered and unique elements. So unordered means what? You cannot access like my set of 0. So this will raise an error. And you can see why is that? Because sets do not have fixed index position. They are unordered. That means you cannot say 1 is in position 0 and 2 is in this position. So they don't have fixed position. So you cannot use an index to get a particular element at that position. So they don't have index positions. Now let's create sets. So here we have an example set, and you can see when I print this set, and what is how can you, and this is a simple set, and how can you define an empty set? Sometimes you need to initialize a set, and you can see here this is how you, or you can simply say s equal to the set, and you can add items or remove items later. So this is a set here, and when you try to print it, it has nothing, so it just prints the set. And when you have, this is the actual set, but when you do something like this is not a set, this is a dictionary. So that is a key thing you need to remember here. Previously we said when you put a list of numbers like this separated by comma, that is a set. But if you really want to define an empty set, you should not do something like this. This is a dictionary. So when I print this, it's going to print this. So if you want to define an empty empty set, you need to do something like set method. So this is a set. So you can see the set methods are coming here. So add, copy, difference, update. But let's see what happens when I use this kind of thing. So this is actually a dictionary. So when I access the methods, so you can see that you don't see the set methods because it is a dictionary. So I see the dictionary methods, copy, clear, from keys. So that is how. If you want to define an empty set, use this initialization, and don't use this one. This is not a set, this is a dictionary. But if you have something like this, then this is a set. So you can see that it has add, copy, but this is not the right way to declare the set. So you don't have that set method. So use s equal to set, and there you go. This is the proper way to initialize a set. And how do we, once you initialize a set, how are we going to add the items? So as we saw here, so we can say s add of 1 and so on. So you can see the output here, 1, 2 and so on. And the same way we can remove the number. Let's say we add 2 and then we add 3. Now we are going to remove the 2 from the set. So all you have is left with is 3 in the set. Now here comes the powerful part, the set operations. As we saw here, this is add, remove, but there are more real world coding where you can use these kind of things. So let's explain it with an example. So here we have two sets. Now if you want to union these sets it's possible in Python with just this single line of code. So when you say A pipe B, let's see what the output is. So what it's actually doing is joining the two and prints this as an output. And see, the duplicates are removed again. And 3 is repeated twice, but we see only one time it is doing this. And we can do other things like the intersection. So what this says is print what is common in both A and B. So what is, as we see here, 3 is the one that is common, and the output is 3 as we expected. And you can also find the difference. So what this means is, give me the contents of A that is not in B. So 1 and 2 are not in B, so it gives the difference. 3 is already in B. If you want to reverse this, it's going to do the opposite. So it's going to print all the numbers in B that is not in A. So it's going to print 4 and 5. So you can play around this and with this. And now let's connect tuples and sets. This is where immutability really meets uniqueness. So here is an important rule. Only immutable items can go inside a set. So this is how it works. So we have here an example where we can put the immutable items only inside a set. So we have an immutable, that is, it cannot be changed, which is a tuple. So we have two tuples, two immutable items. Only immutable items can go inside a set. So you need to make sure you keep this in mind. But if you do something like, so when I run this program, it's going to run fine and print the content of the set. But let me try something like, try to put a mutable object inside a mutable thing inside a set. So something like this. So this is a mutable list, and this can be in the tuple, but that tuple itself cannot be in the set. So you can see here the set ultimately contains a mutable item here, and if I try to run the program, it's going to show an error that it says cannot use tuple as a set element because the tuple has the mutable element list, and mutable element is not allowed in a set. So we need to use immutable only. Suppose I remove this one and put a immutable. So this is totally immutable element inside the list, and this is going to work fine. So anytime you have a mutable element inside the list, that won't work. So this is an important concept that you need to keep in mind. And now let's do a real QA example or a development example. So it applies in both cases. So you can see all the API, HTTP status codes, and you want to print the unique values from these. So you need to use a set. So you just have to define a variable and then say set of the status codes. So set only prints the unique. So you can see the duplicate 200 is repeated 3 times, but the set can only have unique. So we get this unique items. Now you can see the output here. This is very super useful in testing or in development when you're writing unit tests or any other unit test or any other automation code or any other thing where you need to print the unique elements or get the unique numbers. And let's see another example. This one removes the duplicates, but it keeps the logic simple. So when as you can see here, the users contains a duplicate A, and as soon as I say set of users, it's going to fetch the A, B, and C unique items and then store that as a list. And let's see the output. So you can see only A, B, and C, and it is stored as a list. So we get a list item of unique users. And how convenient is that? So now, when should you use tuple versus a set? Let's make it very clear. So you should always use tuple when you want the data not change. Tuples are immutable, so you always use it only when you have data that should not change, and when your order matters, and also when you want to have a fixed structure. But you want to use set in situations where you want unique values like here, and you don't care about the order because you don't care about in your program whether you want to fetch it by index, so you don't care about the order, and you need a fast lookup. Sets are very fast. And let me give you one final mental model. Tuples are locked data and sets are unique collections. So again, for a quick recap, tuple are immutable and ordered, and sets are mutable, unordered, and unique. So what is my advice? You should start using tuples for fixed data and sets for filtering duplicates. You will immediately write better Python code. So if this video helped you, like the video, comment immutable if you understood this concept explained in the video, and subscribe to the channel for more tips like this and other interesting videos. So I will see you in the next one.